there, fourth graders. We are on Module 3, Lesson 23 today, and yesterday we really learned a lot of new vocabulary, and we're going to be using a lot of that vocabulary again today. Okay, today's objective is to use division and the associative property to test for factors and observe patterns. Okay, so we're going to be noticing something about factors and factor pairs. We can either test for them using division or this idea of the associative property. Okay, we're going to look into both a little bit, more so maybe the division you'll feel really comfortable with, but we are going to test some things with the associative property. All right, for warm up here, we just have some prime or composite numbers, and we're going to write the factor pairs. If you feel like you can do this on your own, go ahead and pause the video and then check your work with me, but I'm going to work through this, so make sure you are following along and that you need to, or that you are writing down your notes appropriately, okay? This is really important stuff, so let's see. So prime is a number that only has factors of 1 and itself, okay? So 7, how can I make 7? So 7, I can make 7 with 1 times 7, okay? There is nothing else that multiplies together to get me 7, okay? So I know that 7 is one of my prime numbers, and I'm going to put a P next to it. 7 is prime. So now when I think about 12, I'm going to list my factor pairs, and when I think about 12, I think of a lot of factor pairs here. So the first one I know is true is 1 and 12. That one's kind of the easiest one. Our identity property, when something's multiplied by 1, it stays itself. So 1 is always a factor of any number. Okay, so 1 times itself gets you that number. So the next number we come to, I'm going to just count up. So we have 1 and then 2. 2 is a factor of 12 because 2 times 6 gets me 12. Okay, I'm going to keep going. Now I'm thinking about 3. Well, my factor pair is 3 times 4. If I keep going, so I already used 4, 4, 5, 6 I already have, 7 does not go into 12 or divide. 12 does not divide by 7, 8, 9, 10. Alright, so, and we've gotten up to 12 again. So these are my 3 factor pairs, but it only takes, more than one factor pair to make it composite. Okay, so if a number has more than just this 1 times itself, it's composite. Okay. All right, let's look at 15. So we should be thinking that 1 times 15. Okay, 2 doesn't go in, 3 goes in, so 3 times 5, 6, no, 7, no, 8, no. Okay, that's it. It only has 2 factor pairs, but it's still composite. Okay. What about 17? Might not know, so we might need to check a little bit, but 1 times 17 is for sure. 2 doesn't multiply to get to 17. 3, 4, 5, no, 6, no, 7, no, 8, no, 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 no. So the rest is a no. So this is another prime number. Alright, 21. Be careful on 21. Some people jump to conclusions thinking 21 is prime, so be careful. So 1 times 21, 2 doesn't go in because it's not even. 3 actually does go in. So 3 times 7 gets us 21. So 21 is composite. And those are the 2 factor pairs that work. Okay, so there's a review of our prime and composite. We'll be working with those a lot more as we keep going. Okay, but today let's test for, I'm going to skip that for today. Let's test for some factors. Okay, find the unknown factor for 28 equals 7 times something. Well, something's missing. You probably know already that 4 is missing. Okay, so both of these numbers, 7 and 4, are factors of 28. Okay, they multiply together with each other to make 28. So together they are a pair of factors. Okay, when we think about, is 10 a factor of 28? Well, we can think, does 10 go into 28, or does something times 10 get me 28? And if I think about that for a second, I can multiply 10 by 2 and I get 20. And I can multiply 10 by 3 and get 30. Okay, so 20 is too low and 30 is too high. So no, 28 is not a multiple of 10, so therefore 10 is not a factor of 28. Okay, we'll talk more about that as we keep going in our lessons. But if I count by tens, I cannot make 28. Okay, so that should be kind of an easy idea there. How can I find out if 3 is a factor of 54? Well, we're going to use the strategy of long division that we've been working on really hard in the past couple weeks. Okay, so if I want to know if 3 goes into 54, well, let's test it out with long division. Okay, so if I test this out, I have 3 goes into 5 one time. 3 times 1 gets me 3. When I subtract, I've got 2 left over. When I bring down, rename, I have 24 ones. 3 goes into 24 8 times. 8 times 3 gets me 24, so I have a remainder of 0. So the big thing here when you're testing for a factor with long division is that you cannot have a remainder. Okay, it's got to go in evenly. Okay, so these two up here go in evenly. There's no remainder. So in order to be a factor, you need to have a 0 as your remainder. If you have a remainder, that number is not a factor. Okay, so in this case, 3 and 18 are factors. Okay, so 3, 18 would be listed in a factors list for 54. Okay. All right. This, we're going to kind of figure out a little more about this associative property. Okay. The question on here, is it necessary to divide to figure out if 5 is a factor of 54? Okay, this one you're noticing a pattern. Okay, so if I think about multiples of 5, or when I count by 5s, do I get 54? Do I land on 54 at any point? Well, the answer is no. Right? When I multiply by 5, I'm going to kind of skip some multiples here, but if I'm at 50, my next multiple of 5 is 55. Okay? 54 is not going to divide, by 5. Okay, so noticing patterns like that are going to be really important. Okay, and a lot of that you should feel good with, just because you're good with numbers. Okay, so that's that one. So I can say no. So my answer is no. 5 is not a factor. And this could be your work, right? Counting by 5s here to show that you had 50 and then you had 55. Okay, so that's kind of simple enough. All right. How can we know if 6 is a factor of 54? So here's where I want to practice just a little associative property. Okay, so when you think about the associative property, you think about breaking down numbers and multiplying or adding. It works with adding too. You can multiply and add in any order. So for example of that, an example of that would be 2 times 3 times 4. Okay, so I'm going to write this twice, and I'm going to show you the idea of the associative property. Okay, this first one, I'm going to think about multiplying the 2 times the 3 first. Okay, so I'm going to do this step first, which gets me 6. Okay, 6 then times 4 gets me 24. Okay, so I grouped these together. When I think of the associative property, I think of who you associate with. So think about kind of just the language in that word. Who you associate with are your buddies, your group of friends. It doesn't matter what order or how you're grouped, you're still going to end up with the same, group of buddies. Okay, so associative property is who is hanging out right now. Down here, we can associate this equation a little differently. We can say the 3 and the 4 are going to be our first step. So 3 times 4 will get us 12, and 12 now times this last factor of 2 still gets us 24. Okay, so this idea that you can multiply and add in all sorts of ways. Okay. A good example of this is finding the factor, is 6 a factor? Well, I can break this down. I have 54 equals 6 times 9. That's my fast fact, right? So if I know my fast fact here, I also know that 2 and 3 are going to be factors. This one's pretty cool. This is on the back or the second page of your problem set. And I do want you to try the ones that are there. So you're going to be filling in some blanks of this factor broken down into 2 smaller factors. Okay, so 6 can be broken and made with 2 times 3. So that means that 2 times whatever this equals, so 3 times 9 gets us 27. So we just figured out that 2 times 27 also makes 54. Okay, so it's using your factors and using your fast facts in a way that you're noticing these patterns. Okay, the same thing goes with if I wanted to associate the 2 and the 9 first. So I'm going to rewrite this. So if I had 2 times 9 and I did that first, then multiplied by 3, I would have 18 times 3. Okay, so we just found out that 3 and 18 are also factors of 54. Okay, I think this is pretty cool. For some of you, it might feel still a little tricky, but we're going to practice and look at numbers a lot more. But that is all I have for you today. Hopefully that feels good and that you can work hard on your problem set today. Thanks, guys. Bye-bye.